One type of continuous probability distribution is the uniform distribution. And as the name suggests, uniform distribution is a distribution where the probability of occurrence of the random variable x is equally likely. So x can take any values, but the probability of each of these x is exactly the same. And so if you think about x taking values between a and b, then the probability of each occurrence between a and b is 1 over b minus a, and it's 0 elsewhere. So the best way to understand this or any distribution for that matter is to kind of use an application and then try to see if you can have a plot of that situation and make sense of what's going on. So here let's take an x, which is a random variable which takes continuous value, and the x is defined as the flight time between Chicago and New York, and it takes anywhere between 120 and 140 minutes to fly from Chicago to New York. And so each value or each x in between is equally likely, and that is given by 1 over 140 minus 120, which is 1 over 20. So each x, so probability that x is 120 is 1 over 20. Probability that x is 140 is 1 over 20. The probability that x is 121 is 1 over 20, and so on and so forth. So x takes values only between 120 and 140, and there is zero chance that it is less than 120 or more than 140. And our interest in this application is to think about the probability that x will take values between 128 and 136, right? Now, the probability of 1x is 1 over 140 minus 120, and there are 136 minus 128 possible values that x can take. So each x is having a probability of 1 over 20, and we are interested to find out this area between 128 and 136. This area is capturing the probability that x takes value between 128 and 136, and each is 1 over 20, and you have 136 minus 128 x's values, continuous value, and so that is 8, and that's 0.4. So this area is 0.4. So there is a 40% chance that a particular flight from Chicago to New York will take anywhere between 128 and 136 minutes. The other type of continuous probability distribution can be exponential distribution. Now, exponential distribution is particularly useful when one is thinking about probability distribution of time between events. So, whereas Poisson distribution is interested in number of occurrence per interval, the exponential distribution, the interest is on the length of interval between occurrence. So here exponential is about the time between occurrence or events. And the best way to understand any distribution is through an application. So let's take an application. Let's think about x as a random variable, and that x is representing the loading time at a dock, and on an average the loading time is 15 minutes. Our interest is to find out the probability that x takes value between 6 and 18. So interpretation wise, what is the probability that the loading time will be between 6 and 18 minutes? Again, the best way would be to use a graph to understand what is being asked. So horizontal axis is the random variable, vertical axis is the probability of that random variable or probability distribution function, and then this point is 1 over 15 in this example, which is nothing but 1 over mu, often known as the decay parameter. And given the type of question, the probability density function is less useful because you are going to get probability of a particular value of x, but the cumulative distribution function will give you the probability that x takes less than a particular value. So here the CDF is a little bit more relevant than PDF because we are interested in a range between 6 and 18. So we are interested to find out how much is this area and for which the cumulative CDF will be handy. So probability that x takes a value between 6 and 18 is equal to the probability that x takes less than 18 minutes or equal to 18 minutes minus the probability that x takes less than or equal to 6 minutes, right? So it's basically this minus that area. So this area is capturing the probability that the loading time will be 6 minutes or less, and this area is capturing the probability that the loading time will be 18 or less. And so the difference between that is what will be the probability that it takes between 6 and 18 minutes. So probability that x takes value less than 18, we can use the CDF, which is 1 minus e to the power minus 18 and divided by mu. Mu, remember, is 15, and then minus 1 minus e to the power negative 6, x naught will be 6, and divided by 15, right? And so this is equal to 0.6988, and that minus 0.3297, and that's equal to 0.3691. So there is a 36.91% chance that the loading time will be between 6 and 18 minutes in this example.